So let's work with a second example, another example. And this reads, the natural log of a quantity x plus 3 taking away 4 is equal to 7. Our goal is to look for a value that can be x that after being applied by adding 3 and then the natural log and then taking away 4 is related to 7. So similarly to the previous example, I can write this problem vertically. And we start with our quantity x. And again, we have in our equation little operations that build up to make the big equation sentence make sense. So the first thing and the first operation that's happening to this particular problem is that the value of x is actually being increased by 3 positives. So that's the first little function. And then after being increased by 3, the natural log is being applied to it. So the second function, second operation that's happening is the natural log. After being increased by 3 and then the natural log being applied to it, 4 positives are being taken away. So that's the third operation. And it's all being compared to and related to the last quantity, or the last value of 7. So we have this one quantity being related to the second quantity. And in order to solve for this unknown value, we have to work our way back through by creating the inverses or using the inverses and creating these balances and these identities to discover what our missing value is. So going back through the problem, I can start with 7 and start applying my inverse functions. So taking a look at the first line that we approach is this take away 4. The inverse of taking away 4 is actually adding 4. When I compose an inverse within a function, it creates the identity. So taking away 4 positives and then turning around and adding 4 positives actually create 4 sets of 0 pairs. Moving on to the second one, the second line. The Euler's number and the natural log are inverses of each other. They're transcendental. It's a transcendental number that has its own inverse. So the natural log has its inverse, which is e to the x. So it takes any quantity and kind of puts it in as an exponential number. So these are inverse functions of each other, which create the identity. And then finally, moving along, we can see the last function has its inverse as well. If I start by adding 3 positives, I can turn around and take away 3 positives, and that's going to create 3 sets of 0 pairs. So building all of these together, starting from my second value, the second quantity of 7 that I'm comparing my unknown quantity to, I build up through the problem, and I can see that 7 plus those 4 positives creates an 11. And then I'm going to use that exponential function on it, and then I'm going to be taking away 3. So the solution to this equation is x is equal to e to the power of 11 take away 3. So now that we have our solution, let's test our solution in our equation. So similar to the function composition, I'm going to actually take my x value and I'm going to substitute it into my original equation. So it's going to be rewritten as the natural log of the quantity e to the power of 11 take away 3, then added to 3, finally taking away 4, should be equal to 7. When I see this line, I'm going to apply the associative property. And looking at the associative property, I can easily see that there is 3 sets of 0 pairs that are created. There's the additive identity. So that becomes 0. I can rewrite my line as the natural log of e to the power of 11, take away 4 positives, is equal to 7. Next, I see that the function, the natural log, and the function of e, from my previous slide, I know that natural log and e are inverse functions of each other, so they create the identity, which leaves me with 11, take away 4, is equal to 7. So I know that 7 is equal to 7, and that's true. So my solution must be true. X is equal to e to the power of 11, take away 3.